financial models. Now, we have talked about this last year. We looked at these sort of things. So, again, the formulas here you are going to live and die by. You know how to calculate out simple interest. I is equal to PRT, principal, rate, and time. Again, because these are just equations, you identify each piece, you plug it in, solve. It's not all that challenging. Compound interest. Okay. A, your amount. And your principal. Again, principal is what goes in. Your N compounded how many times per year. R is your rate, T is your time. Again, this is really just plugging it in and putting it in the right spot and calculating. Nothing too spectacular. Let's see. They talk about the different ways of compounding. You got annual, you got semi-annual, quarterly, monthly, daily. And you know that notice that it doesn't turn out half bad. I mean, you get another $2.50 here just by doubling it. But you'll notice that it tends to slow down. It doesn't grow quite as fast as you would think. I mean, if you're compounding it every day, you'd think that would be getting a lot higher. So, kind of gives you an idea of how frequently things go up here. But what I want you to pay attention to is this number down here. We started playing with E when we started dealing with natural logarithms. When I said that this is one of these numbers that tends to pop up every once in a while, sometimes in the strangest places. 2.71 is a number that naturally occurs. If I have something that is being compounded continuously, or a continuous growth function, anything that grows continuously can be modeled by this. Continuous compound. A is equal to PE to the RT. So, if something is always growing, always compounding, and this would be nice, you put it this way, you would not want a bank or a credit card company to charge you interest this way. You would, however, like to invest money and have your interest calculated this way. Again, it doesn't change all that much, because if you take a look here at $1,000, compounded continuously over a year, $5.17. If we go back up here and take a look at compounding it over that year, 365, it's only a penny extra. But if you take into consideration, an extended period of time, it can actually have some meaningful effect with it. Now, one of the things that they are going to be having you look at is something called the effective rate of interest. Now, it's the equivalent annual interest, simple interest. Okay, that would yield the same amount as being compounded. So, I mean, a lot of times you see this advertised at banks for a savings account. Basically, the effective rate of interest that you get. Because it's from the beginning to the end, they calculated, hey, this is how much you should earn if you're following our things and the market is going according to what we expect. Effective, not the actual. The effective rate of return is calculated as follows. So, present value. More formulas. Now, the present value of $8, that's how much it should be right now. We had talked about this last year a little bit when we came to the one that was trying to identify, how much money we're going to make in the future, how much money we're not going to have in the future. Savings, you remember going through that model? This is, again, the same type of stuff. So I was kind of hoping that they had one of those little sheets there in the blue there to keep all those formulas. But make sure that you go and get those formulas down so that you have an idea of what is what. You don't want to be guessing at which formula that you should be using or what the formula looks like. I'm more interested in how you apply the formula and do the calculations with it. So, I know this one's kind of short, sweet, to the point, but please make sure that you get those formulas down, and I'm going to let you guys get to work.